And we're back.
All right. Chapter 6.
Chapter 6 on the road to code. Tell us what you found out about Chapter 6. What was Chapter 6 about, Jonathan?
It was about implementing interfaces and inheriting classes.
We did a little bit of that in the last episode.
Mm-hmm.
We did a little bit of inheritance and stuff. But the interface we didn't do. We didn't do interfaces. And so that's an interesting one. But go ahead.
So yeah, for the beginning, we could start off. He kind of started off talking about kind of like I felt like it was kind of like multiplying two different methods, kind of thing, is what it seemed like.
Oh, the delegates. He was talking about delegates, right?
Okay, yeah.
So yeah. So yeah, delegates and events. As a web developer, you don't have to worry about too much about delegates and event handling.
Okay.
And so let me see. Everybody knows what a Keurig is, right?
Mm-hmm.
Yeah. So when you push the power button on a Keurig, what happens is a couple of events begin to occur. Okay. The very first event is that when it powers on, it checks the temperature of the water. That is an event that occurs when you power on a Keurig.
Mm-hmm.
And if the water is not at the optimal temperature to make your coffee, then it begins to heat it up. It turns on the heater and it gets it to like close to a boiling point. And once it reaches that boiling point, another event happens. The little blue lights turn on and it lets you choose from small, medium, and large size cups. So these are chained events, right? And it's all triggered by the power button. A human goes and clicks on that power button, and the first thing it says, well, I'm waking up, let's check the water. It checks the water. That's the event that happens when you power it. It checks the water, it checks the temperature. The next event is if the temperature is not optimal for cooking for making your drink, it begins to heat it up. The next event is once it reaches that temperature, it turns on the little blue lights to let you know it's like what it is. So those are all chained events, right?
Mm-hmm.
They're all based on the one button being clicked off or being clicked on, I should say. So there's that same concept within programming. When you go and call something, you sometimes want to delegate that. You say, you know what, I'm not sure who's going to handle this, but I'm going to go ahead and delegate this. And so that one delegate that you call is actually going to pass on the responsibility to a method that you wrote. And so when you put the two together, you get delegates, and the delegate that calls the method, the method is actually handling the event of that delegate.
Okay.
Does that make sense?
Yeah.
So did you do the exercise?
I just kind of followed along. But yeah, I saw the example.
Okay, but do you have the code running? Is it working?
Yeah.
Let's look at that code. Go ahead and share your
Okay.
screen. Show me the delegate, the definition of the delegate.
The delegate.
Yeah. Is it in
So
here?
it would be right here. So he did it as a kind of like making a baby kind of thing.
Yeah, yeah. I did see
So
that.
Harry and Mary. made baby. Oh, well, it's right here. So Gary had a baby with Jill and Mary. So that baby's name, well, they just have like two different babies. So yeah, it would be right here. Harry name has Harry children count 3 or 1. Harry children count.
Oh, I see
Mary
what's going on.
right
So
here.
just like you would create a method, what you're doing here is you're saying you're going to create a method out of the operator. The operator is the asterisk.
Mm-hmm.
Okay. And the reason this is actually different syntax than what you're normally are used to seeing, because in most cases you're creating a method, like in line 35, right? You have a public method that returns a person, and the name of the method is called procreate with. That's the name of the method. And it takes a parameter of a parameter called person. And in this case, you called it partner. And then so here it returns procreate. And procreate is down at the bottom. Go down to the bottom. Is it, or is it up at top? Where's procreate?
Yeah.
When you take two people and instead of adding them, you multiply them, what you're doing is you're overriding the operator asterisk, which normally goes and multiplies two numbers. That's the default. Somewhere in the .NET framework, they had to write this exact same code on the integer, on a decimal, on a floating point number, any numeric type. Somebody had to go and write the same line that you wrote on line 41. Somebody wrote this inside the .NET framework so that numbers can get multiplied with one another.
Mm.
So wait, did I just like,
Well, yeah. Just like
yeah, exactly. So you would think that computers, well, it's like, what the heck, man? Computers should know how to multiply, add, subtract, and divide, right? No, somebody had to program it. So what you're doing here is you're taking the multiplication operator, not the plus sign, not the minus sign, not the divide sign, but the multiplication operator, and you're applying it to your person class. So that when you go and take person 1 times person 2, that's going to in turn call procreate. And it's going to say, oh, these two people want to have babies. Mm-hmm. And you call procreate and you create another baby. So yeah, I mean, essentially that's how you would, if you didn't want to use the asterisk, if you wanted to use the plus sign, you would simply go and replace that asterisk with the plus sign.
Oh, okay.
So why don't you go ahead and do that? Replace that with the plus sign. And go change your code so now it uses the plus sign instead of the multiplication. Okay, and then go ahead and put can you debug in here? This is too hard. Let's just go ahead and run it.
Okay. Oh, let me get into this people app. So right here, it would be Harry and Mary. Mary has 2 children. Wait.
Well, we can easily put a console line, right? So go ahead and do after line 24, add a new line and just put a console right.
Console right. Fine.
And then inside parentheses and inside double quotes, just put Here's the plus sign. That way we can easily determine when that call is being called.
Oops. Okay.
All right, let's run it. Save it and run it.
Uh-oh. We broke it. Person.
Oh, because you
Oh,
have
I
to
didn't
save
save
person.
it. Yeah. I got it. All right. Here's the plus sign.
Yeah. So Harry has 3, Mary has 2, Joe has 1.
This one.
And so you can, it's just you're overriding an operator. And the
Mhm.
operator is your plus sign, your minus sign, your modulus sign. So you can override it to do whatever you want, but it should make sense. You just don't override it for the sake of overriding it.
The next part is raising and handling events.
Now, okay, so now we can get back to the Keurig.
Yeah.
So, okay, so show me where you are doing that.
Right here we are.
Oh, so you see on line 43
Mm-hmm.
where you're doing a
Oh,
plus
yes.
equals. So what is the definition of Harry shout? If you right click on that and go to definition on the right side, Harry shout. Okay, so here we go, shout. So that's the event handler. And so the event is event handler shout. So is there a delegate called shout? If you right click on shout and go to definition.
No,
Okay.
it's just different anger levels.
Okay. So right here, what you're doing is you're poking them
Mm-hmm.
and you're triggering an event.
And yeah, it just increases the anger levels
Okay.
until he shouts. I think at 3 it shouts. 3 and 4 he shouts.
Okay.
Something like that.
Open up Visual Studio and let's go and create a Windows application, because in web development, unless you're working with the old antiquated web forms, you're really not going to understand how you would apply this in the real world. And although his example is a really good example, obviously when you poke someone, you're expecting some kind of reaction, and that's really an event, right? That is triggered. And so after so many pokes, obviously they're going to get annoyed, and the event's going to be that they're going to shout. Okay, so we have a form. And so this Windows form, to some degree, is equivalent to like when you open up Word, or when you open up the browser, or when you open up Excel, or when you open up Kindle, or anything like that. It's just
Mm-hmm.
it's a Windows application. It runs within Windows, right? So over on your left hand side, you see where it says toolbox? Expand that and go ahead and pin that.
Pin it.
Yeah. So this is where my C# started with Windows application. Okay. We used to actually create Windows applications to run on actual Windows. And so if you go look for Button. Where's Button? Benjamin Button, where are you?
Here we go.
All right. And drag that into the center. And over on your right, you see where it says properties on the bottom?
Mm-hmm.
Let's go. You see where it says text button 1?
Mm-hmm.
Let's change that to something that says click me. There you go. Press enter.
Mm-hmm.
And so that's the text that shows up in the button, right? And let's go look for a label and drag a label up there.
Here we go.
And set the text of that label to be the button. Benjamin Button has not been clicked yet. All right. So what happens is that this is called a visual designer, okay? So that you don't have to sit there and figure out what is my size of my window and how does that compare to the size of the screen, the resolution, all that stuff is like, you don't have to worry about all that. So this gives you a visual designer. And so, but we still need to write some code. And the way that you write the code in case that button gets clicked is you double click on that button.
Whoa.
And it takes you to some code.
Mm-hmm.
And so in right where you're at, line 22, you can go ahead and say this dot label, because I think the default name is label one. Yeah, label one dot text. So we want to go and target the text equals double quotes. The button has been clicked. So let's run this. Let's just go see that happen. And then we'll come back and look at the code and see what's going on. So if we go, we see where it says form one and then form one designer. Go ahead and click on that designer. This is code that's automatically being generated behind the scenes as you add components to that form. So if you go and expand line 24,
Wow.
it added, you see where it says button one on line 32, it says button one equals new system Windows formed button. And on line 33, it says this dot label one equals new. So it's actually somebody went and created this class, a blueprint that sits in memory. And when it gets loaded into memory, the computer knows what to do with it because it's a blueprint. It knows that it needs to draw a button on the screen. I don't even want to know what it takes to do that because
Yeah, sounds like a lot of work.
it's a lot of freaking work. Exactly. Okay. And then it goes on and it even sets the location on line 38. This dot button one dot location system drawing point 577, 290. In other words, it's taking the upper left-hand corner, says this is where you need to be. Your upper left-hand corner is going to be at those pixels based on the resolution of the screen. You know what I mean?
Mm-hmm.
And then it goes on and it has a drawing size that says the button size is 75 by 23 pixels. And the tab index and the text and all that stuff. So you can see the visual designer generates all this code for you. If we scroll down a little bit, where is the event? Oh, event handler. Here you go. So the button on line 44 has a click event.
Mm-hmm.
And it adds a new system handler. And it says this dot button dot click is the method that you're going to execute when somebody clicks on that button. So events are kind of driven based on how do you say this? Like it's based on like unknown facts, right? Because just like in your example, when you poke somebody, you don't know what kind of reaction you're going to get. But if you keep poking them, eventually they're going to get annoyed and the reaction is not going to be the expected reaction. or not the reaction that you got at first, right? So as designers, what the Microsoft.NET team for the Windows forms, they said, look, we're going to set up a delegate because we need to hand this off to someone else. And so we're just going to go ahead, we're just going to go ahead and set up a delegate on the click of the button. That's going to be a delegate. And then when we put that button on the form, we're going to add a new event handler. And that event handler is going to call this method. And there's some commonalities. I mean, you just can't go and throw this stuff together, right?
Mm-hmm.
One of the things that they said is when you define an event, or when you define a delegate, those need to be defined so that the method that is going to be executed matches a particular signature. So you remember when you created those events that had to match? It's like you created the event, and then when you created the method had to match a certain signature in order for the event to call the method successfully. You remember that?
Yeah.
So this is the same case. There's an agreement basically that says, okay, here's the delegate, here's the system event handler, and the button _1_ needs to match this signature so that the event handler can go ahead and call that. And so they did this for designer purposes, because they didn't know what type of code was going to be called during the click event. And the fact is that you can add multiple events to that click. You can have multiple events. You don't have to call just one event. It could be multiple.
Cool.
So, but that's how it would be used in real world. So if you're building Android application, if you're building iPhone applications, if you're building, any type of native Windows form, WPF stuff, this is how you would handle all the click events. Like, they're basically events that occur based on clicking. And quite honestly, the whole Windows operating system runs on events. In the event that I click the mouse, something's going to happen. But anyways, so that's how in the real world, this is how your events would work. Now, when you're working with web development, it's not quite the same. It's actually very different. Your events are handled differently. There is a thing of adding methods to certain events that happen to components on the web, but they're all happening in HTML, and you call JavaScript in those cases. So yeah, it's different but similar for web development. But when we're writing C#, it's basically just code that's being sent, values that are being sent to the C# code, and the C# code processes it. And there's really no events that you're dealing with. I would think that you could probably get fancy and set up events, but it's not really a common practice. Not something that I've seen in the industry.
So the next topic is implementing interfaces.
I love this topic. This is such an important topic. Yeah. Let me get to that part in the book.
So he explains interfaces as a way of sticking things together. So it's like the electrical, or like a plug in a socket. So that's how it works. And then some common interfaces that he talks about is like comparing two things, or comparing like a first thing and a second thing, or disposing things, so you can get rid of things, and then formatting things. There's different format types too.
Yeah, so everything that you're talking about is built into the .NET framework. And those are all like things that the .NET framework is looking for, but you can create your own interfaces. So let's go ahead and close this out, and let's create a console application. And we'll call this project Working with Interfaces. So interfaces are very similar to that. And I think we talked about this in one of our first episodes, right? Where I said, hey, Jonathan, I need you to come paint my house and I'll pay you $200, right?
Mm-hmm.
An interface can also be considered a contract, right?
Okay.
And so I say I was going to pay you $200, but I never specified how those $200 were going to get to you. I never said it was going to be cash. I never said it was going to be check. I never said it was going to be a preloaded credit card, whether I would Venmo you, Zelle, PayPal, whatever. I never specified how I was going to get you the $200. All I said, I was going to get you $200. That would be the interface, is the contract. The implementation, the physical way where the rubber actually hits the road, is up to me to decide. And I can change it at any time, because as far as you're concerned, $200 is $200, whether it comes in cash, check, direct deposit, Zelle, PayPal, you're still getting $200, right?
Mm-hmm.
That doesn't matter to you, but the implementation is what the person gets to decide on how to do it. So let's create, go ahead and add a new class, and we're going to create this class called, we're going to call it I Cook. Down at the bottom.
Oh,
yeah, you can do it that way too. The first option. And right click on that and rename it. And call it I Cook. Enter. And go ahead and rename the class as well. And you're going to make this, instead of a class, it's going to be a public interface. And we're going to have a method in here. And now the thing about interfaces is that all they contain is the signature of the method. They don't contain the body of the method. So there's no code in here other than just the method signature.
mm-hmm.
So here, let's go ahead and we'll return, this is going to return a string. Yeah, you don't need the return key.
Oh.
The return keyword. You just need string. And then space, and we'll go ahead and call it fry. We'll fry something. So this is going to be the name of a method called fry, capital F.
Capital F, right? Yeah.
Yeah. And then you're going to open up the parentheses, and we're going to receive a parameter. And the parameter is going to be a string. Yeah, it's a type string, not double quotes. And yeah, but you also need to give it a name, right? And so just call it item.
Item.
Yeah. And then close it off with the semicolon. So this iCook interface, it just says the interface is called iCook. And there's a method in here called fry. And whatever you send in as a string, I'm going to do something to it, and I'm going to return to you a string. That's all it says. Okay, there's no, go back to the scenario where it says, hey, paint my house, I'll pay you $200.
Mm-hmm.
It's like, I never told you how to paint the house. You can use brushes, you can use rollers. You know, you're the eye painter. I'm the eye payer. Okay. And there's a method that you have called paint, and there's a method that I have called pay. And how we implement it, how the actual rubber hits the road, neither one of us cares. You're eye painter, and you have a method called paint, and this would be similar like what you have on the screen. And I have an eye customer interface, and I have a method called pay. And how I pay doesn't matter. It's just I need to pay, and there's an amount that you're going to be asking for, right? So let's go ahead and save this. So do a Control Shift S. It'll save all of them for you. And let's go and add another class in here. And so you go right click and add class. The classes are down at the bottom. Yeah. And let's go ahead and on this one, let's call it let's call it deep fryer.
Okay.
And this is a public class.
Why is it doing that block?
Oh, because you accidentally clicked the insert key.
Oh.
Just press the insert key on your keyboard. When I was first working with computers and it would do something like that to me, I was like, man, I don't know how to take this off. I just go reformat my drive, reinstall the operating system. I was like, these operating systems are stupid, man. Okay, so we need to implement that interface, right? And so after deep fryer, it's the same syntax as when you inherit, but this is actually implementing when you do interfaces, right? So you do the colon, and you put I cook, because the deep fryer cooks, right? It says, hey, look, if you're going to implement this, you have to have a method in your class. So go ahead and show potential fixes and implement interface.
Okay.
Go ahead and click on implement interface.
Oh, that I did.
All right. So now there's a method that matches the signature in the interface. You with me so far?
Yeah. Yes.
It says, look, you're implementing this contract. When you implement this contract, you got to tell us now how you're going to do this. So in here, okay, we'll go ahead and we'll do something simple, you know. Go ahead and get rid of that throw. Go and get rid of that line that says throw new, not implemented. Yeah, the whole line you get rid of.
Oh, the whole line.
Yeah. Return the string. Here are your French fries. Else, and if you just tab, it'll automatically create the return, and inside of double quotes say, sorry, can't fry, and then whatever the item is.
Potatoes?
No. So the item, right? Whatever the item is, we don't know what the item is.
Oh, okay.
So remember, you could do string interpolation with the $sign and then inside of the curly braces. The $sign goes in the front of the double quotes. So you got to put in the beginning the $sign. And then inside the double quotes, you can use the curly brace and put the variable in there. And the variable that we want to include is item.
All right.
I don't think you need a space in between the $ and your.
There we go.
There we go. Okay. So let's go ahead and save that. And let's do another one, right? Let's add another class. And let's see. What other stuff gets fried but is not in a deep fryer? What other things?
Fried chicken.
Yeah, but that goes into a deep fryer.
Oh,
Can you?
okay.
Oh, you can fry some eggs, right?
Mm-hmm.
So, how would we do this? Instead of a fryer, it would be a pan,
Pan.
a cooking pan, or a skillet. No, a skillet. Can you fry in a skillet?
Yeah, you can fry in a skillet.
Let's do a skillet. And so it'll be a public class. And this is going to implement the iCook.
How do we do it?
iCook. Yeah, remember the colon. Yeah. And then hover over that error. Show potential fixes. All right. So we're going to do the same thing, right? Where this time what we're going to do is we're going to check to see if the item is eggs.
Eggs. Oh no.
Remember the if statement?
Oh.
If item equals eggs. So in here, item, and then double equals, and then inside of quotes, eggs.
I was close.
You were. You're so close. All right. And then go to line 13. And then in here, return space, double quotes, sunny side up eggs coming up.
Okay.
Else. So you could do the tab, right? It'll fill it in for you. And then so in here, return, sorry, can't fry, and then the item, whatever the item is. So remember, we're going to do string interpolation here. All right, so let's go ahead and save this and let's go to program. And yeah, let's get rid of this console line and let's write, let's say we're going to create an object that is of a type iCook. So it'll be iCook space. And let's just call this cooker, whatever this cooker is. And the cooker is going to be equal to a new blueprint or a new constructor of, let's say, deep fryer.
New deep fryer.
And open close parenthesis. And then go ahead and finish that off with the semicolon. All right. So in the next line, no.
Inside?
Inside, yeah, stay inside. In the next line, you're going to do a console write. And you're going to say cooker.fry. So this is a deep fryer, right? and then you're going to open parentheses. And inside double quotes, type in potatoes or potato. Is it potato or potatoes?
Potato. I think I just put it like that. Potatoes.
Okay. And then close your parenthesis because you got two parentheses that you need to close. And let's run this, see what it does.
Sorry, can't fry potatoes.
Because it's not spelled the same, right?
Yeah.
The comparison.
So I need to go back to my deep fryer. It's capital P.
Capital P, because C# is case sensitive.
Here are your French fries.
There you go. So you can see where the deep fryer implemented the interface iCook, and it had a method in there called fry. And in that, it just says, look, I don't care how you fry or what you fry, but here's what you need to fry, and you need to tell the person what they're going to get back. You know what I mean?
Mm-hmm.
So multiple classes can implement the same interface. This may not seem like anything groundbreaking or anything like that, but when we start doing web development, you're going to see that being able to just not have to go and call a class and just say, hey, look, I'm going to work with an interface, and whatever this interface does is what I'm going to work with, you know? And it ends up being part of a bigger pattern that includes testing as well. Because when you test, you may not want to actually like go and hit a resource. You may want to say, I'm going to do something with this interface, but this interface is really not going to do nothing. It's just going to pretend to do something. And so it ends up working in that sense. And I think as we start working with it, it'll make more sense to you. For now, I guess what's important and what you need to take out of this is that an interface is like a contract.
Mm-hmm.
The class is the implementation. It's the details of how it's going to fulfill that contract. Does that make sense?
Yeah.
How it actually does it, the interface doesn't care. Just like you wouldn't care how I get you your $200. $200 is, that's all you care about.
Mm-hmm.
Whether I give you the cash, whether I Zelle, whether I Venmo, whether I PayPal, doesn't matter. They're like, you just want the cash, and how that happens, it doesn't matter. And that's essentially what interfaces do to be able to acknowledge, to be able to fulfill that part.
Pretty neat.
Cool. What's next?
Next thing is making types safely reusable with generics.
Oh my gosh,
generics.
Yes. All right. So let's continue expanding on what we have here. Okay. Let's create a class. Go ahead and add a new class. And it's going to be called restaurant. Restaurant. Is it UA or AU?
I don't know.
I think it's restar. Try AU. NT. Rest to. Here, I got an easy answer. How do you spell restaurant? RESTAU.
There we go.
RANT. That's pretty sad. That's why we're programmers. We're not English majors.
I've never won a spelling bee in my life.
Neither have I. Wait, maybe in the first grade. But then I lost. Okay, so let's make this a public class. And so generics, okay? Generics, oh, what is the official? It's a way to implement something, but the implementation or the details are defined when you actually use it. Okay. So after the word restaurant, we're gonna open up the greater than less than signs. So put a pair of those up there. Inside that greater than less than, we're gonna put a T, just capital T. Okay. And now in line 9, we are going to indicate that. So let's go ahead and do a property, and you do prop tab. And so normally you see how it says public int because the type of that property is an int. But now what we're going to say is that type of that property is a T. So do a capital T. And then the name of the property is called kitchen.
Whoops.
Whoa. What's going on with your keyboard?
It's doing double. I don't know.
What have you been eating on that thing? So here, instead of specifying that it's an int, it's a string, it's a Boolean, it's a decimal, we're just saying like, look, we don't know what this is going to be until you use this restaurant. When you use this restaurant, then you'll tell us what is T. And then we can go ahead and do whatever we need to do from that point on. That make sense?
Yeah.
So let's go ahead and save this.
Mm-hmm.
And let's go back to the program. And in here, let's go ahead and override line 10, and we'll start actually, let's go ahead and get rid of 9 and 10. We'll start fresh. And here we're going to say var r equals new restaurant. So we're going to, when you call the new keyword, you're saying, hey, take this blueprint and put it in memory. Create an instance out of it. And then inside greater than less than symbols, you're going to say deep fryer. Or no, I'm sorry. You can say I cook. All right. And then outside of the greater than less than, you go ahead and do the open close parentheses and then your semicolon. Now, you notice that when you put the semicolon, it fixes the syntax for you. So just be aware that that's the correct way.
Yeah.
Okay. All right. Start a new line. So r dot kitchen, because that's the name of our property, right? Equals new deep fryer. Open close parentheses, semicolon. So now you can see where the I cook is starting to get some power. Because we're instantiating a deep fryer, but the dynamic type or the generic type is I cook. The fact that a deep fryer is an I cook, it's a type of I cook, or it implements the interface, therefore it's a type of I cook. It says, yeah, this totally works. I can do this, you know? So then you can go ahead and press enter and say r.kitchen.fry. and then open close parenthesis, and inside of double quotes, put capital P, potatoes. And then put that, actually, go ahead and assign that to a variable. So in the beginning on line 11, just put var s equals and then console write s. Yeah.
Okay.
So you see where we told the restaurant, hey, your dynamic or your generic type is I cook. We don't know what it's going to be. And we went ahead and said, okay, the kitchen, which is I cook, happens to be a new deep fryer.
Mm-hmm.
And the program says, like, yeah, a deep fryer, it implements I cook. Therefore, I can go ahead and accept this. And then we assign the value of the fry method to S, and then we're going to console write it. We could have easily put the R kitchen fry inside the console write, but
Oh, okay.
you can see that it's the same thing that we're
Mm-hmm.
doing. So go ahead and run this.
Here are your French fries.
Your French fries, there they go. You know, so we told the restaurant, hey, you're going to need a cook and or some kind of cooking, ware. And I said, okay, yeah, fine, I'll take a cooking ware. And it was like, okay, we're gonna go ahead and build you a new deep fryer. He's like, yeah, a deep fryer is a type of cooking ware, so it matches the I cook, and it says, yeah, I can totally work with this. Let's go ahead and run with it.
Cool.
We're gonna, after this episode, we're actually gonna take a break from this book. We're gonna come back because there's some other stuff that I want to cover, but I also want to get a little bit into what we're going to do in episode 8.
Okay.
Episode 8, we're actually going to start. So at this point, you've been exposed enough to enough C# that we can now introduce yet another technology that's going to be part of your stack, right? And so what we're going to start talking about next week is databases. And we're going to break up next week's episode into several pieces because I want to get into the actual lecture. But I want to separate like the whole installing the database and stuff like that to its own video. So we'll break it up in that sense. But yeah, next week, we're going to start with SQL Server.
All right.
We're going to start working with some databases. And so you have enough HTML in your arsenal of tools. You have enough CSS and you have enough JavaScript to go with. And we didn't do any jQuery stuff, did we? Or
I don't think so, no. Maybe like a little bit.
A little bit, yeah. So I can help you out with the jQuery stuff. I think jQuery is a good way to get introduced into this. Meanwhile, you finish up the Bootstrap and you jump into the React studies, because React, man, it takes everything you've learned about HTML, CSS, and JavaScript, and just like, if it's here and it's like HTML, CSS, JavaScript, it pretty much just turns it upside down, It's like an upside down pineapple cake. You're like, whoa, wait a second, how did this happen? But as you're working and learning React, and you're going to be, I want to say you're going to be such a scatterbrain when you're like, what the heck is going on with this React stuff, But I think once we start we're going to start working with our address book. And so working with our address book, working with something simple, like an address book, is going to help you understand how databases work. And then when we start working with a C# web API, you're going to see how C# interacts with the database. And I think we may do some console applications first, while we interact with the database. And then once we play around with the console application and you get familiar with how to communicate with the database, we'll start working with some APIs that we can then communicate through HTML, CSS, and JavaScript, and communicate with your C# API code that then communicates with your database to go and store data. And so you'll see like all three technologies working together, or is it 5 technologies working together? And so and you get to appreciate, because you're pretty good with WordPress, right? You've been working with WordPress and you've gotten pretty good with it, from an administrative standpoint, right?
Yeah.
So once you start working on this little simple address book, you're gonna appreciate everything that the WordPress developers had done. Because you're gonna say like, man, if this is what it takes to do an address book, like what the heck does it take to do a shopping cart or a credit card payment, all this stuff. And it's like, it really, it opens your eyes up to this like abundance of like so many things that can get done. And you really appreciate all the developers that work at getting these templates and frameworks out there and things that you can just reuse. I mean, just WordPress alone, there's a ton of code in there, and whoever spent the time doing that, man, God bless them, because it has saved it has saved people tons of time to do a simple blog, or a shopping cart or an ordering system. And so doing this little address book, as simple as it is going to be is going to be eye-opening for you. And I'm kind of excited to see that. And so cool.
I'm ready to learn.
Excellent. Yeah, I think we're good. And then I'll start getting the schedule ready for next week. So we got 2 episodes up, and we're gonna put up a third one.
The third one's gonna be tomorrow. Yep.
Cool.
And then we're also gonna have like short little snippets included, just to have the actual episode a little shorter, and then also add some little tidbits that
because we heard everybody saying an hour and a half. My goodness, guys, help us out here. So yeah, and so that people know, like you and I we jumped on this call at 5, right?
Yeah.
And so it's now 8:21. So we spend several hours. And so you really cut down on a lot of things that we talk about, and still leave it so that there's a lot of content there. And that's why we're breaking them out into little snippets that we can do. So cool. All right. Well, I guess until next week when we release a new episode.